Welcome. In this lesson about Introduction to Large Language Models, the intended learning outcomes are, by the end of the lesson, you should 1. Understand and be able to articulate what LLMs are, and 2. Identify some of the strengths and weaknesses of LLMs. By now, many of you may have used ChatGPT or a similar chatbot and discovered that it's able to carry out many different tasks such as translation, classification, and music generation. LLMs are kind of the Swiss Army knife of natural language processing, that is, they are general purpose models that can solve many different tasks without the additional requirement to adapt them through the training to a specific task before using them. They are statistical, usually deep neural networks, models that are trained on big data and have large number of parameters or model weights aimed at predicting the language. GPT-2 is arguably the first LLM based on its parameter size of 1.5 billion and released in 2019. Today, LLM sizes are usually much bigger. For example, the open weight model Llama 4 Maverick is a mixture of experts with a total of 400 billion parameters, though only 17 billion are typically activated. Hence, GPT-2 will today fall in the category of what we call small language models, which usually have less capability. Many LLMs are based on the state-of-the-art transformer architecture, particularly the decoder stack, and are trained on millions of web pages and documents on the internet. LLMs have become easier to use and can be given a directive or a prompt on what to do without any example, which is called zero-shot learning, or may be given examples, which is called few-shot learning. These in-context approaches are cost-effective alternatives to fine-tuning an LLM on domain-specific data. The design of effective prompts in prompt engineering have also become easier because of the increased capability of LLMs. Furthermore, LLMs are increasingly becoming multimodal, that is, they can receive and provide text, images, and other formats of inputs and output respectively. The pre-training stage of an LLM, which can take months, gives what is called the foundation model. The post-training stage, usually involving supervised fine-tuning and reinforcement learning with human feedback, gives the general purpose LLM. As useful as LLMs are, they have some limitations. These include the hallucination or fake facts, social bias, misaligned values, deception. In addition, training LLMs on hundreds of billions of tokens or the words is a resource-intensive and engineering challenge. Hence, we need to rethink and rescale LLMs. Some of the more efficient approaches include knowledge distillation, as was done with DeepSeek R1. There are 3 common methods of knowledge distillation: 1. Response-based, 2. Feature-based, and 3. Relation-based knowledge, all involving soft targets or intermediate teacher predictions. Another is to use parameter-efficient fine-tuning such as QLoRa, involving a 4-bit quantization into low-rank adapters. To measure the performance of LLMs, it is not enough to evaluate a task-specific benchmark dataset, but we should also consider responsible AI use such as energy efficiency, safety, and fairness. Now, as a takeaway task, I will like you to 1. Differentiate a small language model from a large language model, and 2. List, in your opinion, starting with the worst 6 of the weaknesses of LLMs.